Welcome to math class where math makes sense. That's the goal. Welcome to math class where math's our friend. Come feel the math love. Today we're doing transformations. So here we've got three basic functions, x squared, e to the x, and 1 over x. And I've got three transformed functions. One of my favorite ways to teach students how to understand transformations, read them out, get them right off the page, is to write everything in function notation. Okay, function notation for transformations. Use function notation for transformations. Use function notation to read off transformations. What do I mean? I'm going to rewrite G as a transformed F. So this is where function notation is super helpful. Sometimes students think of it as extra, but it's not. Okay, so I'm saying G is 3, and now this x minus 2 quantity squared, that's the input of the function. So it's 3 times f of x minus 2, that's the input. That gets squared, right? So in function notation, I'm not writing the square. And then plus 4. Oh, so I'm seeing what's happening to the base function to create the transformed function. I'm seeing the 3, I'm seeing the minus 2, I'm seeing the plus 4. And now I can read off what those transformations are. So here's the song. A times f of x plus k, a times f of x plus k. To read this off is easy, to read this off is easy. A stretches the y's by a, that's the 3. So I have a vertical stretch of 3. A stretches the y's, and in the song I'm baking in that it only stretches the y values. So when we say vertical stretch, sometimes kids go, oh, it gets skinny. Okay, skinny, fat, like these things aren't as helpful. It's stretching the y values, not the x's. So some point on this curve, the original f of x, the point 1, 1, for example. On our new one with that vertical stretch of 3, it would be 1, comma 3. It stretches the y's. Y's only. Okay. A stretches the y's by a. There you go. Then the next thing is shift up and down by the k. So there's a vertical shift. The mathier word for that is a translation. Vertical shift, let me say up 4. We could say a translation up 4. Okay. Now, set that input equal to 0. Set that input equal to 0. Okay, here's the input. So to figure out the correct transformations horizontally, they're kind of the opposite. We have to undo what's going on. So we set that input equal to 0. So I go, okay, x minus 2, I'll do it here. X minus 2 is equal to 0. Use old math that you already know. Use old math that you already know. Okay, to see how it moves, solve for x. What did I add 2 to both sides to solve for x? The operation that you used, that plus 2, reveals the rest. The operation reveals what happened. It's a horizontal translation or shift, not left to, it's a shift right to. Right to. Okay. Those are your 3 transformations. Do you see how writing this in function notation then lets me read off those transformations? Okay, let's do the next example. The next example is an e to the x function. Okay, I've got this negative e to the 3x plus 1 minus 5. So first, let me write it in function notation for transformations. It's going to be a negative of my function of the input is the 3x plus 1, then I subtract the 5 from that function. The negative, the 3x plus 1 is the input, so it's negative f of, if we're defining f as e to the x, minus 5. Here's the function notation, and now I can read it off. A times f of x plus k. A times f of x. A in this point is negative. To read this off is easy. To read this off is easy. A stretches your y's by A. Okay, so a negative stretch is a reflection. Okay, so we have a vertical reflection. Okay, now remember, a vertical reflection, reflect vertically, whoop, that's over the x-axis. A horizontal reflection, whoop, would be over the y-axis. Okay. Then shift up and down by the k, so then we say vertical shift, or translation, we're saying down 5. That song gives us the order. Stretch the y's, then give down 5. I know it's not a stretch, I know it's a reflection. Kind of bake it all in there. Okay, the song can't say everything. I mean, the song says a lot. So, now, set that input equal to 0. Set that input equal to 0. Okay, this part. Use old math that we already know. Use old math that we already know. This is where it's super helpful, friends. There is a horizontal shrink of a third, and we're going left 1, but students often don't know the order of that. And if you're not doing it in the right order, it kind of messes it all up, right? You're not ending at the correct x value. So what this tells us is it basically shows us where the x value lands. So the x value of 0, where is that landing? What was at 0, what is it going to? Set that input equal to 0. Use old math that you already know. To see how it moves, solve for x. Okay, so I solved for x. It's negative 1/3. That's a negative. What I did was I subtracted 1 and then I divided by 3. Those operations that you used reveals the rest. It's the operations. I first go horizontally left 1. There's that negative 1 minus the 1. And then I divided by 3. Then there's a horizontal. It's a dilation of a third. Horizontal shrink of a third. It's the dilation of a third because I divided by 3. Okay. So that's one way to read off those horizontal dilations. I will show in a video another time the different ways of horizontal dilations and shifts and how we can rock that. But for now, we're going to leave it here, okay? Because there is a different way that we can describe that. All right, great. Those are the 4 transformations. And so the final one, final example over here, I'd have to write it in function notation for transformations. Use function notation. So m of x to read off transformations. Okay, the x plus 1 is that input. It's where the x was. The 4 is getting multiplied, and then the minus 2. And now using function notation, I can read it off so easily. A times f of x plus k. To read this off is easy. A stretches the y's by a. So vertical stretch of 4. Then shift up and down by the k. Then down 2. Vertical down 2. Now set that input equal to 0. Set that input equal to 0. Use old math that you already know. Use old math that you already know. See how it moves, solve for x. The operations that you use reveals the rest. What would I do? X plus 1 equals 0. I would go minus 1 from both sides. So it's a horizontal left 1. I would go minus 1. The fact that the horizontal transformations do that opposite of what you see is not counterintuitive, friends. It is perfectly baked into what's happening to the function. We have to maneuver those x values first, and so we're kind of undoing what we did, all right? I can, of course, go into more explanation another time, but this video was about understanding the lyrics. So there you go. I hope that helps you unpack 4 transformations. It's a song off of Funky Functions. Use it, love it, subscribe, stream, share, follow, spread the math love because math loves you. Bye.